Hello and welcome to the Green Business Podcast, where we meet exciting climate entrepreneurs. I'm your host Bharti. Today I have with me Ravi Nuguru, who is co-founder of Nanospan. Nanospan specializes in graphene and graphene-based additives. So graphene, as we know, is a wonder material. It was discovered in 2010, and the guys who discovered it won Nobel Prize. It has many functionalities, and because of which it has potential to decarbonize a lot of our sectors. So let's unpack more and welcome Ravi. Hi Ravi, welcome to the show.
Hi Bharti, thank you for inviting me. It's a great pleasure connecting with you and your.
Yeah, lovely. So Ravi, you are a tech professional, right? You worked in Cisco, Juniper Networks. So what is it that led you to switch to graphene and nanospan?
Yeah, so I've been working in a multi-domain environment all through my career, starting with electronics, and then biomedical, power engineering, and later the data networking, hardware, software. But I was always interested in the materials. Materials was my favorite subject. So after my previous startup, which we had in Silicon Valley, I decided to do it in graphene because graphene had actually captured my imagination. Its potential. I just could not wait without working on graphene. So I studied it for a couple of years with my colleagues in Japan. And then later we decided to form this company, which focuses on graphene, which can, actually change the economics of a nation. Really, it has that much potential. Yeah.
Yeah, that is a superhero vibe I get whenever I talk or read about graphene. It is thinner than our hair and it is stronger than steel. It is just too much to comprehend. So can you unpack that for me?
Correct. So one of the biggest draws of graphene is that there are hundreds of applications because, as you mentioned, it's the strongest, lightest, most conductive, highly thermally conductive, hydrophobic, and so all these will mean that almost every application you can imagine adding value.
Right.
The real I think the challenge is how to focus on one domain and then make it commercially viable. I saw a lot of my peer companies. They got drawn into this promise of graphene, and they spread very wide. So mostly, I think the efforts were in R&D, but because graphene comes in so many forms, so many. I can actually explain further, but cost, the cost, etc.
Right.
It takes a long time to really bring it to commercialization. So that's why what we did is we had three basic the objectives. One is make graphene in a sustainable way, because graphene can be made in, again, so many different ways. Most of them are chemically they're chemical based, and we wanted to do it in a sustainable way, and we chose that one of them. Another one is we wanted to stick to one or two areas and really work on that to bring it to commercialization. The third one is, of course, making it commercially viable, which means the pricing, the quality, and all these processes, right? If you don't take care of that, then again, the whole effort will be wasted. So we focused on these three. So the first one we have a very good, the patent. Currently, the patent is published for the production of the graphene itself. That is in a sustainable way, where we don't use any toxic solvents, nor do we have any toxic byproducts out of our process. The second one is we chose two areas today which need real the help from the sustainability point of view. One of them is the construction, another one is the energy storage. Because the construction segment, it is one of the highest, second highest carbon dioxide emitting industry.
Right.
And the energy storage, even though it is meant for the green energy, the EVs, particularly the EVs and the battery making process is very polluting. So we chose the one in the battery making process, which we're using graphene, graphene composites. We were able to come up with a process where we made the wet process into dry process for the electrodes, and then we bring multi-fold performance in the batteries using graphene. So these two together, again, they bring down the carbon footprint. So we were able to prove that we could bring down the carbon footprint by more than 25% in construction on any given construction. And then in the energy storage, we actually simplify that process where we not only bring the carbon footprint down, we also bring down the manufacturing costs and all the the costs of dealing with the pollution aspects of the materials, right? So these two are our focus areas. So
Yeah. Okay. So before we go to your focus area and what Nanospan does, so can you talk a little bit about how it is made, what does it look like, and why is it the superhero that it is, it is called?
Yes. So graphene is the carbon allotrope, because if you look at, I will share one small.
Yeah, sure.
You can see it, right?
Yeah.
So carbon allotropes, have been in use for almost like 5 centuries, right? There have been several generations of them, starting with graphite to carbon black to carbon fiber, all the way to nanotube. A lot of these things changed when the graphene was invented in 2011. And then this graphene brought so many features into it that the most of the today's the advancement or the R&D has been focusing on graphene. Now, if you look at this small the picture here, graphene is like a two-dimensional material, which means it has a length and breadth but zero height. So you can imagine an elephant sitting on a pencil on that surface that can still hold. That's how much strength it has, right? So and also the another important thing is this is widely available, which means it's available. For example, in your graphite pencil, when when you foliate that, you will have graphene. Graphene is nothing but, if you take graphite, it is layers of graphene in there. So what we do, what one has to do is exfoliate that the graphene from inside that graphite layers. So that's where the technology is. Or there is another way where you actually assemble the carbon atoms side by side. They call it the CVD process, but that is the most precise and also very expensive process, right?
Fine.
If you want to see the real graphene. So what happens is, so we when we do this, we get graphene in different forms, which means different number of layers, different flake size with different properties. So if you look at that here, the highest end, it's like diamond, right? It is as strong as diamond. And if you the other end, you will get multi-layer graphene where some of the properties are reduced, but then they become cost effective. So depending on your applications here, you choose what kind of graphene you want. So first you should have your application in mind, and then you can come up with the graphene characteristics that you need, because to make that, because not all features will be applicable to all applications, right? So for example, here we focused on construction battery material.
Right.
So you can see that. Which means the cost has to be lesser, but quality can be higher. Has to be higher, particularly for those properties. So that's why we actually characterize the graphene. What kind of graphene we need, and then as of the features, you just already told. All it's 100 times stronger than iron, and then it's a very highly electrical conductive, so there's a lot of superconductive applications are also being done there. And then surface area is what determines its effectiveness, right, or for any chemical agent kind of thing. So this is one of the very high surface area, and the nano engineering actually helps that. And water repellency, this hydrophobic, it's like a lotus, a layer. If you put water, it doesn't stick. That's another great property that we use for our construction. And it's inert, it doesn't react like chemicals.
Right.
So these are the main properties. Yeah.
Okay.
So this graphene
when
platform
we see,
actually. Yes.
Sorry, I have a question. When we see sugar crystal also, it is two-dimensional only, no? So why is it such a big deal for graphene to be two-dimensional?
No. When I say why the nano part, the height is 0.
Okay.
That makes it nano. Okay. Almost close to 0, which means it's nanometers, right?
It's flat. Yeah. Okay.
Yeah, it's a flat. For everything, if you it has a height. If you see, we are talking about a nano which you can't see with eyes.
Yeah, understood.
Nano comes also, we say it's almost close to 0. So that's why it's a nanomaterial, right? Anything that has a nano dimension is a nanomaterial. This one, in addition to being nanomaterial, it has all these properties.
Okay. So among the nanomaterials, this is the only material that doesn't have 3D. It is only a 2D. It has no height. It has length and breadth, which makes it a high surface vis-a-vis its volume, right? That's what you mean.
That's why we call it a 2D material, right? Yeah.
Okay. And graphite is like a rock, and there are different layers, and you are extracting one layer mechanically. That's what you do, right?
That's correct. So the graphite, it can be mined or it can be synthetically made. So synthetic graphite usually comes from the petrochemical, the byproduct, wastes. Right. They make the graphite. Usually the synthetic one is more suited for many applications because it can be the purity can be controlled. Whereas the mined graphite comes in different purity forms, which means again you need to purify it to the way you want later on, right? So we use, we use synthetic graphite, and once graphite also, when you see it, it's a powder again, right?
Okay.
It's very difficult to distinguish between each of these materials. Graphite, the first one can be a rock kind of thing, but again, what is available in the market is usually a powder form. So with that powder form, you take it through all the process and then make it graphene. We use what is called a liquid exfoliation, because there's mechanical exfoliation, chemical exfoliation, liquid exfoliation. Liquid exfoliation is environmentally friendly, but we have done a lot of enhancements to that to make it the quality and the performance that we need out of that.
Okay, and it becomes sustainable because you don't need chemicals, or it needs less water to make it?
Yes. So the chemical process need a lot of the sulfuric acid and all these very highly toxic solvents as well. So we don't use that approach. Everything is for exfoliating, right? From the graphite, if you want to exfoliate, there are so many of these processes. Those are not sustainable ones, unfortunately. And there's a plasma engineering engineered ones, but that requires very high energy. Again,
Right.
that one is sustainable, but not so much from the energy point of view. Whereas liquid exfoliation, we find it much more sustainable, because even the byproduct that we get or out is actually recyclable. It is actually, when I say recyclable, it is actually used in other products. It's not gone waste. Yeah.
And challenge is that if you want a great product, then the cost will be too high, but find a product that meets your needs and commercial requirements as well, right?
Yes. So what is one thing that the approach that we took from the beginning, looking at the market today, I think one of the biggest the problem you see in this industry for the graphene industry is that if you have an application in mind,
right.
If you want a graphene that is suited for that application, if you want to get that in bulk in a reliable, cost-effective way, it's very difficult. There are no, really suppliers who could do that. Even if you can do that, they can do that. It becomes expensive because of all this engineering that they have to do for you, right? So until this supply chain comes up on that side, we decided to do our own graphene the way we need it for our applications. So that's where I think we find ourselves, control of what we are doing. So a lot of our competitors, people who are on the application side, they really, don't know why their graphene is not working, because they source it from other places. The people who are actually supplying graphene, it is very difficult for those people to really keep up with so many applications, because everything has to be functionalized to the application, right? To a given application. So because the costs and the IP involved, I think the ecosystem is not still developed to do that at this moment. So I would say the best approach is for anyone who is doing graphene application, just think about doing from the scratch for now. For another 5 years, I think that's the state will remain like this. Yeah.
Right. Okay. Shall we just remove this slide now? Is that done or?
Yeah.
Yeah. Okay. So, so like you said, the skill is in figuring out the composition of graphene that will work for your end products, and then also you have to make the additives, right? You have to use this graphene in a way that it is useful to a particular application. Correct?
Yes. So, yeah, that's correct.
Yeah. Okay. So let's go back to Nanospan and what you do. Please talk to us about what. So you do graphene, yes, but you sell this graphene or you convert it to something else and then sell that?
Yeah. So as I mentioned, most of our R&D initial, we've been in business for the last 7 years now.
Right.
So most of the time, these 7 years, we've been improvising our graphene process.
Yeah.
Or IP in the IP process. But then our final aim was to really take this to the market, which means we came up with these additives for the construction and for the energy storage mainly.
Okay.
When I say additives for energy storage, actually we sell in energy storage, we sell the electrode material itself, right? Electrode material and the electrodes. Yeah. And when in the construction, we sell the additives that go into the concrete.
Okay.
So wherever the concrete is used, we find a medium that is suitable for the concrete, and then we infuse the graphene in there. So that's why we bring the enhancements. So the problem statements, if you look at the business aspect of it, what is that we are really bringing? Leaving aside what graphene brings, what is that we are bringing to the customers? What is the problem we are solving for the customers?
Yeah.
That's where most of our focus is, because that's what really makes any product successful, right? So coming to that, what we are solving in the construction, let's say, is construction today is, as I mentioned, it's very polluting, and one of the second highest carbon emitting process.
Right.
The other part of that is, you have all these climate events increasing every day, and the sea levels rising, which means most of your construction, particularly in the coastal areas or the other constructions, they have to deal with the damage caused by the water,
Right.
acids, and also extreme temperatures, right? Which means one has to use very durable concrete for every construction, really speaking.
Good.
Now,
Understood.
this is where the durable concrete is like a rocket science almost today, because there's so much goes in there, particularly different kinds of additives, the secondary reinforcement materials, the time it takes for the design and testing, etc. It becomes like very expensive compared to the regular concrete. Regular concrete has some characteristics, but if you want to bring the other aspects into that, the anti-corrosive, make it complete crack resistant, all these kind of things, it becomes prohibitively expensive. So what we could do is we have brought an additive that can be put in the regular concrete.
Okay.
And you get a durable concrete out of it. So we simplified that whole process of making durable concrete. That way, this durable concrete is kind of democratized, and you can use it. You can make it easily, and it's cost effective, and you can use it everywhere. So this is what we offer through our additives.
Right.
Now we have 4 or 5 additives like this, but the same family that we sell, that goes into the regular concrete, that goes into the precast concrete, that goes into the bricks, the aerated autoclave bricks, and then recycled concrete. And nowadays you have what's called a blended cement concretes, which means a lot of these byproducts like fly ash and all these kind of things are used in that. So all these need help with. That's where we are. Yeah.
Okay. So your and it makes cement more sustainable. I understood. It makes cement stronger, and it makes cement sustainable. How?
Concrete, actually.
The
concrete. Cement is one aspect of it.
That's true. It makes concrete sustainable. How does it do that?
So what it brings is it brings the power of graphene into the concrete in simple ways, right? Which means it increases the strength, right? Okay. When it increases the strength, you can afford to actually use lesser cement.
Less cement. Okay.
That way, lesser cement, lesser the redundant whatever I would say materials. Like there is a material microsilica, there are fibers. You can bring them down. Without here, we don't add the weight to the cement. That's the good part of it.
Understood.
The other parts also add that part, the weight part too. But you can eliminate all that. It becomes much simpler.
Okay.
And you get very strong concrete. You get a waterproof concrete inbuilt, and then your concrete will be very crack resistant. So I can actually go through one, the picture, a scanning electron microscope picture that explains everything. Why the way the graphene works in concrete, and why it brings all these features, right? Including the anti-corrosion properties.
Okay. Yeah, if we do it in 2 seconds, we can do it. Let's do it.
Yes. Okay. So here you see cross section of the concrete. Okay.
Right. Yeah.
On the right side, you see what is the current conventional concrete with the conventional admixtures, as we call it. The left side, you see when our additive, the graphene additive, we call it spanophrase, is added.
Superhero concrete.
Yeah, for the concrete. So if you look at the right side, at 30,000 zoom, when you zoom to 30,000 times, you will see all the pores, which are the pathways for water, for cracks, etc. And if you do further to 120,000, you still see them. No matter after doing the same mixed design, you see all these holes, which later can become problem, right? The corrosion or the water entry, again cracks developing. This is where they cause. Whereas if you see this, the bottom right side, the same 120,000, you see they're nicely stacked layers, which do not have entry points like the one that you have on the right side, right? Nicely, densely settled concrete with with no entry points for the water, and this being an inert material, it actually also adds to the anti-corrosive nature, and no, it doesn't give entry to the cracks.
Right.
So that's what, and you can see, that adds the strength as well, right? Compared to the one we have the other. So we bring all these because of this additive. We make it easily usable in the concrete, because one of the problems people will face is dispersion into the concrete, right? You can put graphene powder in the concrete, but it has to disperse correctly, right? So we make it dispersible actually. What our composite does is that it disperses very nicely,
mixes well,
uniformly. Like it's a liquid-based additive. End of the day, that goes like water. When you add water, you add this one as well, along with everything else, all other the mixed design elements, and then it brings a structure like this.
Good. Okay, got it. And the other product does similar things to electrodes, right? Electrode material.
Yeah. Electrode actually is a different one. Electrode, there are two aspects. One is graphene is the best product for making what's called a supercapacitor. Supercapacitor is actually it increases the power density, and then it also can store energy. Right. And it is quickly chargeable. So there's no other material better than graphene. So graphene is quite popular for that. The other part that we use for graphene is, for the lithium-ion batteries. Today, people use graphite as an anode into the lithium-ion batteries. But the next generation material is silicon. Silicon can bring almost 10 to 20 times the energy density of graphite.
Right.
So most of the R&D you see happening is actually on the silicon side. But one of the problems with silicon is that it has this swelling effect when you charge and discharge.
Okay. And
a couple of other problems. What we do is we use graphene to control that swelling.
Okay.
So that's where our technology comes, our patent. We have the patents approved for making that, as well as for the dry electrode. Again, I mentioned we are doing the wet process way, we do the dry process, right?
Correct.
Process usually. So we are probably another year away. We had before we commercialize. Yeah.
Right. Okay. And lastly, Ravi, what are the so there are so many good things to graphene, and but what are the challenges of working in graphene?
Yeah. So graphene had really, a lot of people got enamored with graphene, but at the same time, because of the issues that I mentioned, the supply chain,
right,
and the approach that people have taken, there have been a lot of heartbreaks. So there is some skepticism in the market about graphene. So one of our challenges is to get past that skepticism outside, from the customers. Okay, graphene is great, but does it work, or does your product work? This is the one, right? So that is where we are spending, because now we have the proof is in the pudding. We have the product that is geared to doing something specific, and then we make it work with the customer, and then when the customer uses, they have this confidence. So I think the graphene, the real the commercial stage has started now in the last 1 year. I would say a lot of changes have been there. Before that, we had much more skepticism, but now it's not. People are already using. For example, today our concrete additives have been more than 2 million bricks.
Okay.
Already have a graphene in them commercially in India, and then there is almost 25,000 cubic meters of concrete is already using our additives in several different type of projects. Whether it's a high-rise buildings, roads, tunnels, industrial flooring, data center flooring, the all types of extreme temperature concreting. Yeah, we've been doing well there. We definitely you show our USP in there.
Right.
Yeah.
Right. Yeah. Lovely. And then next product is like a year away or something. Right?
That is energy storage. Our primary focus today is the construction, sustainability in construction.
Right.
That's a really very exciting projects are going on out there. Energy storage, that's our next. That's where we want to go. Finally, actually, what we want to achieve is energy storage in construction, in the bricks.
Okay.
Yeah, that's our holy grail, right? So that's where it will head to eventually. Yeah.
All right then. Thank you so much, Ravi, for your time today, and it's lovely connecting with you.
Thank you very much. Thanks for the opportunity.